Last section, solving systems. We've solved systems. We can solve systems in our sleep. Where two lines cross, someone could wake you up in the middle of the night and be like, where do these two lines cross? And you would be like, hey, give me 1 second. Oh, they cross at 3, -5, right? No sweat. Substitution, or that was elimination, but we are also equally good at substitution, right? You've been learning this since what, 7th grade? Yeah, 7th grade is usually what people say, yeah. And so here we'd have -11y is equal to 11, so y is -1. I can plug that into my head and get x is 4, ordered pair 4, -1, right? Life is good. Systems, 2 lines, got it. Well, guess what? Now we've learned more shapes. So we've learned parabolas and lines, which, by the way, we did that already with quadratic systems. We've learned circles and ellipses. We've learned, circles. Those ones wouldn't have no solution, by the way. So now we're going to do the same thing. And we're going to sketch some little graphs here because we're going to look at these and say, hey, number 1 is a parabola, not making it perfect, right? And the second equation is a line, down 1 over 1. Now, if I wanted to be really precise, I could probably just solve that by graphing, right? And show those ordered pairs. But we always are going to show our algebraic work. So we're going to do this one by substitution. X minus x squared equals -2. Or if I move everything to one side, x squared minus x minus 2 equals 0. You should recognize that as quadratic really quickly and being able to factor in. Now when you get those answers, is that an ordered pair? No, that is the x values of the ordered pairs that are the solutions. How do I find the partners? How do I find the y's? Right, plug them in. So this is 2, what, -4, and then -1, -1, right? Yeah, there you go. So those 2 ordered pairs are the solutions, and obviously you could check and make sure you got them right. Try the next one. What shape is the first equation? Right, a line, right? Slope of 1, y-intercept of -1. What's the second equation? Right, a circle. If I wanted to graph that super precise, I could, and I could find, maybe even read them directly from my graph. But we're always going to show an algebraic solution, another substitution. X squared plus x minus 1 squared equals 25. Now we got to be careful. What do we got to be careful of? We don't want to get what? Foiled again. So we want to make sure that we FOIL, right? So here, 2x squared minus 2x minus 24. Can I make my life easier? Sure can. Divide everything by 2, right? X minus 4, x plus 3. Like you're kind of home free really at this point, right? X is 4, x is -3. What do those numbers represent? Those are the x coordinates of the ordered pairs, which are the solutions. How do I find those y coordinates? Plug them in. Does it matter if I plug them into the line or plug them into the circle? Most certainly does not. 4 minus 1 is 3. -3 minus 1 is -4. 2 ordered pairs. And onwards we go. Now here's the nice thing. The graphing is actually optional. If it's an easy graph, I graph it. If I look at this one, I'm like, I don't really feel like drawing that ellipse and hyperbola, and I can tell right away that I can just add those 2 together. That's going to drop out. X is plus or minus 2. Don't forget your plus or minus. When I plug that, back in there, either positive or -2 is going to give me x squared of 4. 4 times 9 is 36, right? And then any way I slice it here, I'm going to get, y squared equals 0. Plus or minus 0, same thing as 0, so plus or minus 2, 0. No graph needed, right? You could if you wanted to, but usually on these where, it's just going to take me too much time to draw that graph, and I can easily get the answer by then. So x is plus or minus 3, plug it back in. You could probably tell along with me that the y is 0, so plus or minus 3, 0. So solving systems of equations.